Good morning everybody, myself Acharya Vishvendra, and today I shall be discussing a worksheet on the spherical drop, basically the pressure inside a spherical drop. It was a question asked in PYQ JEE Advanced, so let's discuss the question. So here is the question that we are being given a spherical drop of radius capital R and the liquid of density D is filled in it. Then the first question is mass of liquid. So mass is density into volume. Volume is 4 by 3 pi r cube. So this will be the mass of liquid. The next is weight of liquid. Weight is m into g, so that will be the weight. Next is acceleration due to gravity at radial distance small r. So we know that inside the solid sphere acceleration due to gravity is gm by r cube into small r. Next we have graphical variation of acceleration due to gravity. So inside liquid it is proportional to r inside the sphere, and outside proportional to 1 by r square. Then we need to find excess pressure inside a shell of radius small r. So here the radius is small r, and we consider an elemental shell of thickness dr. So there are two opposite forces. Gravity will try to contract this shell, and since this shell is stationary, so certainly there has to be a force due to pressure which should be vertically outward, so that the two gets cancelled out and the equilibrium of the shell is maintained. So we can say that if we calculate force due to pressure, it's excess pressure into area, and that should be equal to the force due to gravity. So P excess into area is dm into g. Dm is density into 4 pi r square dr, which is the volume of the elemental shell, and acceleration due to gravity is g by m by r cube into r. So after the calculations we get the excess pressure as gm by r cube dr into dr. Here dr is the elemental radial width, which is shown over here like this. This is dr over here. So we can say that excess pressure is proportional to r. So if we draw the graph, that will be a straight line, and for capital R that will be like a rectangular hyperbola. Now we need to calculate pressure at radial distance small r. So as we have said that excess pressure is this. So suppose internal pressure is P1, external is P2. So excess pressure is P1 minus P2. We take P1 as P and P2 as P plus dP. So we have minus of dP is gm by r cube dr. So we get this expression. Now if integrate this from P0 to P and 0 to r, after integration P comes out to be this much. Now if r is equal to capital R, that is at the very surface of the the sphere over here. So since there is no liquid over here, so the pressure has to be 0 if we assume that it's placed in vacuum. So at r is equal to r, P0 is 0. From here we can calculate P0 as this thing gmd by 2r. If we draw the graphs between P0 and M, that will be a straight line, and P is equal to this. Now we need to find pressure at small r is equal to r by 2. Just substitute the value. We get the pressure as here. Now if we see the graph between P and R, so the graph will be a parabola and it will be 0 at r is equal to r. So the graph will be like this. So you have seen that it's a basic level worksheet. Although this question was asked in PYQs, and it was based on this expression like this. So 10th question was directly asked. There were multiple choice questions on that. So if you know the concepts well, it's actually the fusion of two different concepts, one from gravitation and another from fluids, and using integrating that, this question has been created. So I hope this question will improve your efficiency and will give you an idea of how questions in JEE Advanced are framed. So I think it will be very beneficial to you. Thank you and have a nice day.